Proceed.
Oh, hello. My name is Jeff Kramer. I'm the author of Infinite Resources, and I'm here with Roger Carlson, the author of the Saving the World Before Breakfast series. And together we're saving the world before breakfast with infinite resources. And today we have a special guest, Dr. Barry Prentice, and I'll just go ahead and read his introductory bio. So Dr. Barry E. Prentice is a professor of supply chain management at the University of Manitoba and the president of Buoyant Aircraft Systems International, Inc., or BASI, and the ISO or Isopolar Airship Association. In 2002, Dr. Prentice organized the first Airships to the Arctic conference. This began public interest in Canada of using cargo airships for northern transportation. In 2005, he co-founded the ISO Polar as a not-for-profit institute to coordinate airship research, cold weather testing, and to hold further airships to the Arctic conferences. In 2011, Dr. Prentice established Buoyant Aircraft Systems International, which I presume you pronounce as BASI, is that right?
Yes, that's correct.
Okay, BASI, to undertake airship and drone research at a newly constructed hangar at St. Andrews Airport. A 24-meter airship was built as a research platform, and a smaller 18-meter radio-controlled airship was flown to test systems for shipment of supplies to remote communities and mines. The entire research facility and aircraft were destroyed in a violent storm in 2015. Their website, www.buoyantaircraft.com, that's BUOYANTAIRCRAFT.com. Since that time, BASI has focused on the development of an electrically powered, hydrogen-filled, remotely piloted rigid airship for cargo transportation. And this is the short bio. Dr. Prentice gave us a long one, and it documents all of his research papers. And I think you said you had over 400 papers published. Is that right? And he's headed all sorts of organizations, appeared at all sorts of conferences. So this is a very brief introduction to his accolades. So with that, Roger, did you have any comments that you wanted to make before we get into Dr.
I think
Prentice's
we'll have the comments after we get the presentation, and I'll take any or well, maybe this is a good thing. Would you like to wait till after your presentation for questions, or would you like to have them anytime?
No, I think we do them as we go. It's more interesting that way.
Okay, excellent. All right, I'll do a share and get your presentation up. Okay, is it visible at your end?
Yes, it is.
Yeah, I can see it.
Okay, just tell me anytime you want to go proceed.
Do you want to go to full screen or just go through the slides? Because we can see the border around the presentation.
Okay. Let's see, it should be right. I might end up I'm hitting the presentation node, but other things are going.
I suppose it doesn't hurt anything to go
showing the other things. So that way, this will be easier to, in case we want to duck back.
Sure, that makes sense.
Fine with me. Well, let me just start off by saying thank you for the invitation. It's very kind of you to show some interest in this technology. We've been working on this for a long time, as you can understand. In fact, this presentation was first made at the conference in Europe, in Nuremberg, in 2023. And in fact, there's another conference coming up at the same place, almost the same time, in Nuremberg this fall. So it was a very successful conference. And my presentation deals with the economics of cargo airships. I'm an economist by training. So this is my area of expertise. Next, please. Some of the economic implications for cargo airships. First of all, just generally about economics of transport, it's a derived demand. Nobody sends freight for the freight to enjoy the trip. Is how do you get it there, and how do you get there at the lowest cost and fastest, the best shape, and so on. And of course, transport itself is a service. So it's very perishable. You either move things when you have a chance, or you don't, and you miss the opportunity because you can't store transport services and have it the next day. It's either now or never. There's a spatial dimension to transport, which is always interesting, and that is that the value of a service depends on the direction you're moving. Freight that's going one direction often pays more than the freight coming back, and we refer to that as the front haul and the back haul. And of course, there's no two locations or transport routes for that matter that are the same. Wherever you're going, cities are of different sizes, resources are different places. So it makes transport a very unique topic in that respect. And of course, there are many economic trade-offs to be considered in terms of transport, dealing with such simple things as speed and distance that you're going. If you want to go further, you'll have to have more fuel. But if you carry more fuel, of course, you won't be able to carry as much cargo, depending on what kind of vehicle you're dealing with. And we'll come back to that. And finally, safety must always be the number one priority. Now, people may think when people talk about the business of transportation that, oh, it's all about money. In fact, any transportation company you talk to, you'll find that the very first thing they're worried about is safety. And it's because safety is so expensive if you get it wrong. Regulators are very intolerant about accidents, especially in this day and age. In fact, one of my colleagues said that the airlines are the only industry he knows where one accident can put the firm out of business. And we can think of some examples. Swiss Air is one. There was another, I forget the name of the airline. It was a low-cost airline that one of its jets ended up in the Everglades, and that was the end of that company. So safety is an extremely important issue. And of course, there are extreme regulations involved in aviation, next only probably to nuclear power in terms of how many regulations and safety features you have to have. So it's something that has to always be brought in mind as you're thinking about transport, and especially a new form of transport. In a way, airships are, and they've been around for 100 years, but for most people, it's really still very much a new area. Next, please.
Oops. Oh, I'll get it. There.
So the economics, there are submarkets, and the freight itself determines what the transport mode is. So, for example, you can have larger capacity freight, overdimensional. We always talk about flagpoles, trying to ship a flagpole or a wind turbine blade these days. It's very specialized freight to move that. And of course, there's a whole industry involved with very heavy overdimensional freight, sometimes referred to as buff, big, ugly freight. Speed and urgency of delivery, that's another area where, of course, most people, they want faster rather than slower, of course, but depends on the cost. There's an almost one-to-one relationship in transport between speed and cost. The faster you go, the more costs. And of course, depending on how urgent delivery is, you can make a choice between getting it slower at a lower cost or paying more. The general handling can become a very important issue depending on what the freight is. Obviously, low-cost commodities, grain, lumber, iron ore, general handling is not a matter there. In fact, those are products that you can use and ship in bulk because you can use mechanical handling. But the more valuable the product is, by and large, the more general handling is needed. And sometimes just because something is big doesn't mean general handling isn't necessary. An example of that is a transformer for an electrical power station. A very big instrument, very big piece, but quite delicate as well. So bigness doesn't mean you don't have to be gentle with it. Reliability, of course, this is a function of the mode of transport. Some modes of transport are more reliable than others. The most reliable form of transport, in fact, is a pipeline. Guaranteed almost you're going to arrive. Weather isn't going to affect the pipeline. And the least reliable is actually aviation because it's most susceptible to weather. And ocean transport's in between there because it's also difficult. Trucking tends to be more reliable than rail. Not they're both moving over land, but trucking has a manager on every vehicle, where the railway, of course, is a much more complicated network service and going through yards and so on. So reliability is less with the railways. So this combination of attributes, what is it that you need, will determine what transport you're going to use, but also has an influence on what the design of the transport vehicle is. And again, we'll come back to that later on. So transport service providers must size themselves to the demand. All of the instability in transportation lies on the demand side. The transport services are there, and they're only needed if they're going to be used. But of course, if the demand fails, you go into a recession, all of a sudden there's too many vehicles. You go into a boom, there's not enough. The demand is where you have all the instability, and of course that determines the size of transport to accommodate that market. And of course, finally, to obtain profitability, you have to have utilization. There's an old expression that the truckers have: if the wheels ain't turning, you ain't earning. Bad grammar, but very easy to understand what they mean. You have to keep the wheels turning to make money. As we always talk about, a hangar queen is an aircraft that's sitting in the hangar. It's not making any money. Next, please.
You're there.
I think it's one more.
Slide 4.
Oh, sorry. That's number 2.
Down. One more down.
Down one more.
Oh, almost at it. Next one.
That's 3. One more down. You're having some problems with the mouse today, apparently.
Okay, sorry.
Right. So the economics of cargo airships, at this point, they're largely theoretical. We can't really say at this point that what they are, simply because no cargo airship has been designed and flown in commercial usage in modern times. We do have some pretty good ideas based on scaled prototypes that have been flown. In fact, one has just been flown this past year, actually the past few weeks, over the San Francisco Bay, which is the first rigid airship flown in 87 years. And this is the LTA research company, and they're on their way to a commercial airship. So we're soon going to have this information. But at this point, much of what we can say is more about the extrapolation of the old rigid passenger airships. They're not cargo airships. And also some experience about the non-rigid inflatable airships, the blimps, the Goodyear blimp is an example of that. And then some guidance from economic theory. So just a caveat in terms of what we can say about airships in terms of being precise. We know approximately, but we can't say precisely because, again, they're not there yet. Next. So revenue depends on utilization and cycle times. Now, cycle time is a term used in transportation where you're looking at what is the full time it takes to leave your destination with a load, take your load and drop it off, pick up another load somewhere, and return back to your home. That's a cycle. And it depends on the sorts of businesses you have, but the number of cycles you can do in a year determines the total revenue you can get. And so that utilization and cycle times are key to how much revenue you can earn. In terms of your costs, a lot depends on the size of the vehicle. The bigger the vehicle is, typically, the lower cost per ton mile of carrying goods. A ton mile is used as a kind of a way of comparing transportation systems. So what is the cost of moving 1 ton 1 mile, or moving 1 kilogram 1,000 miles would be the same. So in any case, the economies of size, and again, I'll return to that concept in more detail. Economies of distance and negative externalities. Obviously, there is an issue about distance because you have terminal costs, your loading and unloading, as well as the movement in between, which is called your line haul. And those costs, of course, add together to give you your total costs. And then you have negative externalities, which the firm may not, well, almost by definition, the firm doesn't pay for externalities. These are costs that are borne by society, and the ones that we typically think of are pollution and congestion. So you don't pay anything for congesting the highways, except you're slowed down yourself. And in terms of carbon emissions, for example, causing greenhouse gas effects, you don't pay for that right now either. Economies of scope, how much or what can you use your vehicle for? How limited are you in terms of its utilization? If you don't have a market for one thing or action, can you do something else? The more you can do, the better. And finally, safety risk and uncertainty come into the operations. So next, please. This is the little diagram of cycle times and opportunity costs. It shows a front haul and a back haul. So a full cycle is the round trip, but the thicker line, front haul, depicts it being paid more in that direction and less coming back. If the firm cannot get any cargo, the back haul being empty, there's no revenue. So it must make all its revenue from the front haul. So we could say you have to charge round trip costs. Railways tend to do this because it's very hard to find return loads for a lot of the rail equipment. So a lot of the rail equipment goes one way full and comes back empty, but it's easier for them because they're mainly capital costs. They're fixed costs and their variable costs are fairly low. So coming back empty, lost utilization, but not a lot of direct costs because of that. Trucking, of course, is the opposite. Mainly variable costs. So the front haul back haul is very important for trucking. And I'd say airships are about in the same category with airplanes. Next. This just illustrates the trade-off of distance and speed. The faster you go, and this particularly applies to airships, the faster you go, of course, the more resistance you're facing, air resistance, the more fuel you burn. So if you go slower, you burn less fuel and you can go further. So there's a trade-off between speed and, of course, the amount of tons that you're covering, or ton kilometers you're making. Bearing in mind also, of course, that airships are really constrained by weight. So if you have to load on more fuel, you can't load on as much cargo. So the faster you go means less freight you're going to carry as well as less distance you're going to go. So there's some really interesting trade-offs in terms of operations into what is the appropriate speed for an airship. And of course, this will depend a lot on what's the commodity being moved and the capital cost of the airship. So it's more complicated than just simply, let's go at this speed. Next, please.
And I was going to say, you're going to have a third dimension would be the cost. And the slower you go, the more cost.
Yeah, the more capital, well, the less utilization you get, and therefore more capital cost.
Right.
Yeah.
That was the thing that killed the shuttle because they sat in the hangar for 6 months being refurbished. So a smaller thing would still be just whether you go 60 miles an hour or 80 miles an hour.
Yeah, it's a really interesting game. It's not something that people normally think about too much because we normally think about, a speed limit and on a car or vehicle and you go at that speed. But there is a sweet spot somewhere there, and it really does depend on several factors.
Yeah, including how many Smokies are watching on the freeway. You go 100 miles an hour.
Yeah, the fines come right off the bottom line.
Hmm.
So this illustration is used to look at cycle times and vehicle size. We did some modeling on this with the airship that we have designed to come up with what would be an effective freight rate, bearing in mind there has to be a profit margin and also looking at one-way trips. And we did this in terms of looking at transportation to the north. So if you're looking at a 250-kilometer trip with a 30-ton lift airship, it worked out to be, and these are Canadian dollars, 47 cents per kilogram. And if you're going twice as far, 500, well, it worked out to be a little bit less than double at 82 cents. If you get to a 60-ton airship, these costs fall, I guess, by about a third. And you get to a 100-ton lift airship, they fall by about half. These proportions you see down below are approximately right. A 30-ton lift airship would be about 600 feet long. A 60-ton would be in the area of maybe 75 feet, or sorry, 750 feet long. No, sorry, 600, 700, and the last one 800. So you get a lot of extra lift as you get longer because you also get fatter, and therefore you displace more air, which is how you get lift in the first place.
A quick question on that then. That's assuming that you're getting the full utilization of the 30, 60, and 100 tons then?
Yeah, we're looking at this as being a year-round service and, with appropriate times for loading and unloading and weather and so on. Not 365 days a year, but, something like 300 days utilization. Again, you're going to have days that are weather, you're not going to move things. You have to face that. And also there's going to be inspections and some possibility of maintenance, repairs, what have you. So you can't, shoot for 365 days utilization, but you want to get them out as much as possible. For airships are like ocean-going ships. They don't go in a hangar very much. In fact, most airships, the ideal would be about 2 weeks a year in a hangar. And half of that would be for inspection, annual inspection. They live out in the sky. And an airship actually is safest up in the sky because there's nothing for it to run into or anything else, and it floats around and does its thing. So, and of course, that's how you make money. So, getting high utilization rates in an airship, much higher than an airplane, which has, of course, a lot more maintenance because if an engine fails, well, you're in deep trouble with an airplane. In an airship, well, you float around like a balloon if all engines fail. So, again, you could lose all of them and not be a problem. At least not initially. You can let down somewhere. Next, please. This just illustrates the principles of the economies of size, especially for what are displacement vehicles. So you can see on the right-hand side the size of tankers. So a coastal tanker at 205 meters that carry about 25,000 tons. The Aframax at 245 meters, about 50 tons. The Suezmax at 285 to get to 100 tons. And of course, 300 meters gives you 200,000 tons. And then finally, the ULCC, the ultra-large crude carrier, will give you 400,000 tons. So the economies of size in any kind of displacement vehicle are really important, and bigger is always better. Again, on the bottom picture is a historic shot of a Goodyear blimp beside the Graf Zeppelin. And the Goodyear blimp is about 200 feet long, and the Graf Zeppelin is a little less than 800 feet long. The blimp would lift maybe 2 tons, maybe 3, and the Zeppelin 70 or more. So you can see the size really has a strong impact. There's also an interesting issue with regard to materials. The top left is a pipeline, and it's also the same sort of principle that the bigger the pipe, of course, the more you carry. But what you can also see is that the width of the walls increases as you get bigger. And that's called the hoop stress, which is why blimps which have no frame are really limited as to how big they can get. Because it's just a question of how strong is the material. The bigger the diameter, the greater the stress. And so you get someplace where you're kind of the dog chasing its tail. If you have to get a heavier envelope in order to get the bigger size, but then you're too heavy for that, and you have to keep going back and forth. So the notion is that yes, bigger is better, but some things don't scale as you'd expect, and therefore you have to be careful with the sort of technology you're talking about. There are limits. Next. This just illustrates a point of looking at airships versus trucks. Most people think that airships and trucks, there's no way they compete because the roads are free and the trucks are relatively inexpensive. So how could an airship ever compete with trucks? And of course, the answer is that it certainly can't in any kind of short distance. But with size, of course, the trucks are basically limited by the dimensions of the roads and the bridges as to how big they can get. But the airships, we don't know how big they can get. We know that 87 years ago, they got to roughly 100 tons of lift. With today's materials engineering, would 200 or 300 tons of lift not be possible? And if so, would they still not compete with trucks? Well, we know they won't compete on short distances, but would they necessarily not compete with long distances? The next picture, please. And this illustrates the economics of distance. So in the case of trucks, there are constant costs per kilometer, per mile. The further you go, the more it costs, and it's just pretty much a linear relationship. The airships, of course, start off with a much higher fixed cost, but then the cost per mile is relatively flat. So there is some point X at which that distance, anything to the right of that distance, the airships could compete. Anything to the left of it, they could not. We've done some calculations on an airship that would carry about 100 tons, looking at moving fruits and vegetables from Mexico to Canada. And that X is about 3,500 kilometers. So that's a long trip for a truck. It takes 4 to 6 days crossing borders and so on to get to Canada. But at that distance, the airships could actually compete bringing fruits and vegetables. We looked at tomatoes in our study, and we concluded that the tomatoes would not just look like tomatoes, they'd even taste like tomatoes, because the trip would only take 20 hours, and the handling is very gentle. Again, something that people don't appreciate about an airship is that there's very little movement or vibration in an airship because they're so big that the actual movement's very, very gentle. The old Zeppelin operators used to put a glass of wine on a shelf, and they told the passengers, if that wine glass tips over during the flight, we'll refund your fares. They never paid out once.
Wow.
So you can actually ship much more ripe or riper fruit from Mexico, 20 hours, or from further south, for that matter, and have much better quality than we have today. The dashed line that you see represents the notion of externalities. So these trucks are giving off carbon emissions and so on. If we actually charge for the carbon emissions, then that X that we see would be quite a bit moving to the left. I don't have the airships doing that because the airships of the future are all going to be electric, and we're looking very much at hydrogen as a fuel source. So no carbon emissions. So if we do start to look at carbon emissions in trucks, that distance would be shorter. Of course, trucks could also change, electric trucks and hydrogen-powered trucks. So, I don't want to make too much at this point, but certainly against current diesel trucks, that they would be much more competitive if you counted all the costs.
Yeah, I'm
Yeah.
not sure if you mentioned it. So what's the difference between the MSC and the MPC?
Oh, the MPC is what's called marginal private costs. This is what the carrier pays for their service, their truck, their gas, their labor, what have you. The MSC is the marginal social costs. This is the cost that's borne by society, which is the private cost plus the externality. So that's the MSC.
Yeah, I would say some other externalities would be particulates from tire wear and tire wear on the tires and particles torn off the road by the tires and brake particulates, which
It's a
have
very good point. You're absolutely right. I lived on a busy street once, and it was amazing the kind of dirt that came into our house just from the tires
Mhm.
wear. You know, one of those things that kind of dawned on me once is like, yeah, bald tires. Well, where does that material go? Well, of course, we know it goes into the air, and we all
Mhm.
breathe some of that material. So you're absolutely right. Accidents could also be included, as well as noise and congestion. I mean, there's many other factors that are involved in
Mhm.
transportation that are externalities.
Mhm. Oh, I have another economic thing as far as cost versus distance. How about island places or multiple islands, places like Philippines, Indonesia, the Caribbean, where you're moving things, and versus then you're competing probably against small boats, especially if you're delivering to a small island. Or British Columbia is another place.
Hawaii as well. You're
Yes.
absolutely right. Any place, island nations are actually very much handicapped by transportation.
Mhm.
And we also look at the Canadian Arctic for trying to patrol or deal with the defense in the Arctic. It's also the
Mhm.
same sort of thing. A lot of islands that are there. Uh, in, it also applies to trade. We in North America we tend to think a lot about truck and train because we do a lot of trade within North America. But of course, anything that's outside the US or Mexico is going to move in an airplane or a boat. And some countries, they don't have a lot of other choices. Australia is basically an island, as is Japan, of course, is an island. So anything they move has to go by ship or by airplane. And the one is very fast and very expensive, and the other is very slow and relatively cheap. There's nothing in between, which is what we have in the case of North America and land-based transport. So the airships could fit that middle area. And even other countries you may think of, like India. India is sort of like a diamond shape with the Himalayas at its top, seas on two sides at the bottom, and only a little area that is connected to land to the Middle East and goes through some nasty countryside with, or at least nasty neighbors. So not so good to transport as well. So there's a lot of places in the world where airships would be very valuable for international trade, not just, of course, us with tripping to Mexico.
Mhm.
Next, please.
Okay.
So this is the idea of what we call economies of scope. What things can you do? So an airship that's moving, say, general freight most of the time, if there's a need, it could do project freight or emergency response.
Mhm.
Project freight would be like a wind turbine blade, which is a specialized move. And emergency response, of course, if there was a hurricane and places were knocked out, you could divert the airships from there to go and serve that capacity. We look at this as for Canada and the Arctic defense. It'd be very hard for the Army to have enough airships on standby waiting in case there was an oil spill or some need in the north. But if we had airships serving the mines in the north, if there was a cause for an emergency, those airships could leave the mining operation for a week or whatever, go up, serve the oil spill or whatever the need is in the north, and then come back to work. And this actually is operational today. They're called standby contracts. So the military often has standby contracts, certainly in the US with airlines, to move people when they need to. And so it's a way of looking at economies of scope. So the more things you can do, essentially what this says is the better option you have for staying busy, and that's the production frontier. Next. So risk, safety, and uncertainty. Again, this is the classic diagram of probability and where you're going to be. And of course, you have to actually operate very much in that below that upper tail in terms of any transportation. You just simply cannot afford to have accidents, which means the ground handling, the crew training, everything about this adds more to cost the operating aircraft than it does the surface transport. Next, please. So now let's look at some airship markets. So how do we apply these principles to the various designs for airships? So in terms of cargo markets, you can imagine there's, I guess you could say I'm looking at 4 different types of markets. Short haul and long haul general freight, so perishables, building materials, etc., as well as low density freight. One of the things that people don't appreciate is that most trucks that are on the road are actually underloaded. Even though they may now have a 52-foot box or 53-foot box, they still cannot necessarily reach the full weight, depending what you're shipping, because a lot of things, of course, have a lot of packing around them, and things have gotten lighter. Think of a wall-mounted TV, a thin-screen TV. I bought one recently. I was surprised at how light it was, but even more surprising is that the box it came in was at least 4 times the size of the TV because it had all this foam packing around it. Well, again, if you're shipping that product, you're not going to get a full truckload. With an airship, your only limit is weight, simply because they're so big in general. There's always lots of cargo space. So they are very good for low density freight. Not so good for high density freight because obviously they're limited by weight. So they can move it, but it's better at different other transport if you have it available. Some things though, like perishables, again, it's fruits and vegetables I mentioned. Building materials, some building materials are quite bulky. Kitchen cupboards, drainage hoses, septic tanks. These things take up a lot of space, rafters. So, moving those by airship to the north would make certainly a lot of sense. Project freight and aerial craning, short haul and long haul. Project freight, as I mentioned, overdimensional freight typically is what we're looking at here, not overweight, although it could be in terms of road limits, because most trucks are limited to how much you can actually carry, and you have to very specialized trucks if it's overweight. And of course, short haul and long haul. Some aerial craning companies may only be short distances. Cranes tend to be limited. The heavier the weight and the longer the reach is a problem. The heavier the weight is, the shorter the distance you can be away from the main mast. So you can only reach out so far in a crane, and therefore, an aerial vertical type lift with an airship would be interesting.
Yeah.
Resource extraction, forestry and mining, and then finally, the military and military logistical missions.
I'd say a question in there would be another competitor's helicopter craning things for lumber, for instance, or skyscraper building with the same sorts of things. Cranes too big, or it can't go cross country into the forest.
That's true, and helicopters are used for those purposes. We had a helicopter putting an air conditioner unit on top of a big building because they couldn't get a crane up there. So, and of course, putting up something very high on a tall tower, helicopters get used, and they are used for what they call stem harvesting of trees. They take off all the limbs and then just take the stem out as well. But the difficulty with this is just really high costs. Helicopters are, and also their limitation as to their weight. Most helicopters don't lift more than a few tons, 5 tons being pretty big. There have been some built as much as 10 and 15 tons, but again, you don't find many of those around.
How about multi-bladed ways for them to get larger things
You know,
and
the
or hybrid airship and crane?
Yeah, that's an interesting idea, and people have actually come up with those kind of designs.
Mhm.
The difficulty with a hybrid is you're never sure whether you're getting the best of both worlds or the worst of both. And we've never actually seen one properly built and tried, so we don't know. But it is an interesting concept for sure, because the notion would be that the airship would lift the dead weight of the vehicle, and then you'd use the propellers to lift whatever weight you want to move. So it has certain appeal to that because you have more control. But again, have to see it done. Next, please.
I had a quick question with regard to the lumber industry. I think it was at Expo 86. I was watching or talking to somebody who was involved with a project that they wanted to develop, and they were talking about the same application you were mentioned, where they're using helicopters to take out the trees. But I think they had like a rotating sphere airship that used the Magnus effect for extra lift and stuff.
Yeah,
Are you familiar with that project?
absolutely. Yeah, no, I am very familiar with it, and Fred Ferguson was the guy who was behind that, and they were trying it. They never were able to really make the Magnus effect work as much as they'd hoped it would. But what happened in the 80s, or actually it was the late 70s into the early 80s, oil prices had spiked tremendously. Those of us who are with some gray hair remember the the shock around the world when the price of oil tripled from $3 to $10 a barrel, and we all thought we were going to freeze in the dark. And everybody ran to find every kind of energy efficient system they could find. And people suddenly realized that the airships were a possibility. And that brought back a lot of investment. And some of the people who were very much involved in that were the forest industry. They've been using balloons, trying to do some logging with balloons, which is very dangerous and difficult to do. And they actually invested in some research to do that. And there were some attempts that looked interesting, but by the time these things got to sort of the place where they might have gotten commercial, the oil price collapsed and all the investment petered out in the airships until another 20 years later. So, but that was an operation, and again the same reason. The benefit, interestingly, of helicopter logging is that a lot of the wood gets shattered when you fall a tree. And if you have a very valuable tree like a cedar, then laying it down gently, actually, that's what pays for the helicopter to do it. Really a interesting sidelight on that industry. So here we have some pictures of rigid airship designs. And in this first case, if we're looking at the types of airships, these have some kind of frame. You can see the one picture in the middle on the left. You can actually see the frame. That's a new design, and those sort of crisscrossing piece you can just see through the material. Those are carbon fiber tubes, which is very interesting new development in terms of the industry. And this is LTA Research, who's the first rigid airship, as I mentioned, 87 years is now applying. This was a smaller test design, you can see by the side of it, but the one they have built and flown is about 400 feet long. Down below is the French firm, Flying Whales. That airship is actually designed for logging. They received money from the French government to develop an airship to remove logs from their Alps and to bring that into operation. Mountains are probably the most difficult place for an airship to fly. Elevation, of course, the higher you go, the less you can lift. But the real problem is all the Venturi effects when you have mountain passes and valleys, and the sun coming up and heats one side of the valley, and then as it passes over, heats the other side of the valley, and the wind moves with the heat of the air. And so you get these really difficult, sometimes strong, unpredictable winds, which as an airship, that's not ideal. This one that you see is not their latest design, but they have rows of propellers on both sides to hold this airship steady when they're taking logs on and off because of that design. A couple of these, this is Worldwide Arrows. This was a demonstrator built for the U.S. Army, and it's about 400 feet long. It got off the ground, but just barely. It's sort of what they call this a hybrid design. What they really mean, and this was one that was actually a Russian military design. The firm moved to Israel, and that's where they are now, Atlas. Both these firms are still, actually, all these firms are still in business. The Atlas one is sort of a combination of the different shapes, but it's never been built. Neither has the two above it. The one above at the very top is our design, and it's sitting on what we think is one of our major innovations is rotating base. And you need a rotating base if you're going to have commercial operations. And I'll come back and talk about that perhaps at the end. And of course, the one in the middle is the Variolifter out of England. So a lot of people have put forward airships, and some have actually been built. But of course, there's got to be twice as many other paper airships, I call them, that would like to be built as there are existing.
Or CAD airships now, not even paper.
Exactly. Next one, please.
Okay.
So these are blimps, essentially no frame involved. Hybrid airships is what they've been referred to in the ones that are kitty corner on the bottom right and the upper left. Same basic design, same basic designer. The one being built by Lockheed Martin has now been spun off to a company called AT Squared, which is trying to commercialize the vehicle. The one on the bottom, Hybrid Air Vehicles, they have orders for an airship, and they're setting up production in England to produce them. These are both, well, they can carry anything, but the Hybrid Air Vehicles is looking at passengers, short-haul trips, Belfast to Liverpool, I suppose, or maybe it would be Vancouver to Victoria, maybe just across the Great Lakes. Short haul trips, and they're also looking at the Shetland Islands, serving those.
Mm-hmm.
This is also an idea for tourism, and I think an interesting market for nature tourism. You know, the problem with ecotourism is that how do you get people to see wildlife without disturbing the wildlife? And how do you get enough people there in mass to be able to do that? Looking from an airship would be a really nice way of doing it. We have a good example of this very close to home here. Churchill, Manitoba is known as a polar bear capital. And there's about a 5 to 6 week season. The bears are close enough to Churchill going out onto the ice, and the ground is frozen enough that they have a tundra buggy, like a great big bus high up so the bears don't get you. And you can go out and you can see the bears on this prescribed trail. But that's 5 to 6 weeks, and that's it. After that, the bears go out onto the ice hunting. But the bears are there all summer. It's just you can't get to them because they don't allow you going out on the tundra, damaging the tundra, which is very delicate, with any vehicles. People do go out in helicopters, but they're restricted too because they're too noisy. They chase the bears. Airships being very quiet would be something that would be able to see the bears more year round. In fact, the mayor of Churchill and I have a secret wish to have a little locator tag put in the bear's ear and be able to find them out on the ice during the wintertime. And so people could go out and actually see the bear hunting on the ice, which would be really remarkable to do that.
Mm-hmm.
Anyway, you can also see a couple of other designs, Brazil and Argentina. Many people trying this industry.
Yeah. As far as observing and touristing up in the sky. The original balloonists, they often remarked how they would hear conversations down below them, as it, they might only be they might be 400 or 500 feet above the ground, but the sound had nothing to obstruct it. So it was an excellent thing, and especially if you'd be electric and have your propellers away from the bag, which leads to these non-rigids. Might they be semi-rigid to keep the propellers on the side from drooping the fuselages down on either side?
You'd think so, although these, I've seen them and they actually will work this way. They have long round circles that are tapped onto spread the weight out. The one down below from Argentina, I think is actually more realistic. Because one of the problems is the pressure. When you start going fast with an airship, you'll push the nose in. So it would limit the speed they could go. So the one down below, that design actually has some merit in terms of that. One thing about airships, you're right about the balloons. We've talked to a lot of the folks that are moving the advertising balloons across the U.S. South. They go from California to Florida into football games. They say they see all kinds of wildlife, deer and whatever. They look up and they see the airship, but they don't pay any attention, don't get scared, they don't run away. So you really can get up and see the wildlife. And I think the one that I have a dream of seeing is whales. I was on a trip to see whales on a boat, and you see a fin here and a bit of a spray over there, but you don't really see the whale. Where you're up in the air, you can actually see the whole whale. I've seen drone shots where you can see the whole whale. So, being in an airship would be a wonderful way of seeing the whales and also, again, not disturbing them when you're watching them. So I think that's an interesting future.
Yeah, because the whales would they hear the propellers and things because they have very sensitive hearing. And of course, sometimes it comes up like, hey, we can play with these guys. They might give us some food. And for porpoises, they'll ride on the bow wave and such. But yeah, something way up in the sky, they haven't been hunted by any air things. Like some of the fish would duck away, but the whales would have no problem.
So I had a few thoughts on that too. So first of all, with Churchill, Manitoba, and the polar bear buggies that you mentioned, when I was in university, I went to school with a fellow whose grandfather started the company that built those buggies. It's
Okay.
Foremost Industries out of Calgary. Another really good potential tourist industry for airships would be I went and flew down over the Nazca lines, and they take you up in these tiny little four-seaters. And I was trying to, film, and it took me about half a minute to get airsick. Luckily, luckily, I didn't literally get airsick, but I was like sweating bullets and stuff for quite a while after that. And the whale watching too. Yeah, I've experienced the same thing where I've taken a tour out of Los Angeles area, and we got to see some porpoises, but you don't get the whole full effect of that, which is pretty. Which would be very amazing and not as disruptive to the whales, I'm sure.
Yeah.
I actually did a paper at a recent conference to look at the possibility of the future. Could you combine airships like the hybrid air vehicle one, along with cruise ships? Because one of the issues is you need enough passengers to make the airship profitable, and they're not going to be that cheap, and people have to stay someplace. If you're out in the wild areas, so a ship going through the Northwest Passage, for example, we'd be able to transfer people to the airship. They can fly, see different things, come back to the ship and stay, or especially up the coast of Alaska. There's some really beautiful places that would be nice to see from the air. So maybe the future will see some combination of cruise ships and airships in the tourist business.
Yeah, that's a neat idea. We were on an Alaska cruise last year, and by the Hubbard Glacier, and it's one thing to see it from the sea level perspective. I'd imagine it'd be just incredible to see it a few thousand feet up.
Yeah. Yeah.
Similarly, for tropic places, like Caribbean, again, Hawaii, you can see there's atolls that near the surface and things. And of course, the thought would be, hey, like the Hornblower in San Diego, uh, dinner cruises.
I think a service out of Cancun, Mexico would be interesting. I had the opportunity to be in what actually was a hot air balloon, a powered hot air balloon airship out of Mexico City, and we went to see the pyramids north of Mexico City. And you get a very different perspective of what's going on from the air than you can see from the ground. So being able to cruise and see the pyramids, the jungle, the sites, and of course, again, a place like Cancun has a lot of tourists. So, you need to focus the airship where you have a large number of markets back to utilization, economics, and so on. But that would be one of those I think would be a real winner as well.
We were in Cancun a few years ago, and we didn't do the Chichen Itza tour because it was something like 3.5 hours to get there. And of course, the same for the return. And you only got to spend a couple hours there. And now they don't even let you climb up the pyramids anymore and stuff. So, but certainly having an alternate way of getting there, which would be quicker, presumably, and we give you that different viewpoint would be certainly of interest.
Yeah, airship tourism is one of those things which I think actually is going to be a very big market. It's completely untapped right now, but it's one of these sort of once in a lifetime experiences. Anyway, we should move on because we're running all our time talking about tourism. These sorts of airships are interesting. The Russians seem to like these. They tend to be a lot of them. Luftschiffs in Germany is another. But this is the notion of what they call lenticular airships, which are basically a disc. And of course, it's a very strong structure, very good for moving loads and being steady, to the wind, holding them in place as a craning device. Has a lot of interest. Moving them through the air is more difficult because, think of dropping a plate in the water off a dock. You see it slide sideways to sideways getting to the bottom. Well, the disc in the air wants to do the same sort of thing. So you need a tail if you're going to go any distance. Anyway, it's something that's being worked on, and we could well see this sort of airship in the future too.
Yeah, I was kind of wondering about how if you'd work it with propulsion in 8 different directions, or like you say, you have to have a tail so it's always going in one particular direction, and you've got it's not totally lenticular because you got a big tail on the back.
Oh, it's interesting. Maybe as we move into the drones, these things could turn. If they were turning like a frisbee, then it'd probably be much more stable. But again, that's something that's maybe going to be in the next generation of airships.
Yeah.
So if you go to the next slide, please. So now I'm going to look at, these different designs and what I see as their markets. So in terms of long haul general freight, basically falls out of what I said earlier. You need high speed, streamlined design, minimum fuel use. You're going long distances and you want to go relatively fast. That's why the Zeppelins took that shape. But the one you see in the top, by the way, that is the picture of the LTA research vehicle called Pathfinder 1 flying over San Francisco Bay. And that's only a few weeks old. So that's the first, as I said, rigid airship in 87 years, all electric, flies beautifully. And, it's got half a dozen propellers on the sides and some at the ends as well. So a very unique design and a lot of hope for our future. Obviously, ability to handle sling loads or pelletized loads. You can carry things below an airship without too much difficulty. It doesn't really affect aerodynamics very much. So that's something that people do and can do. Climate control, cargo space, not hard to do. What you do need, though, is rapid ground handling and safe ground handling. There's no room for accidents. There's no room for mistakes. And you can't spend all day loading and unloading. You won't make any revenue doing that. So that ground handling issue is one that we've actually worked on quite a bit, and we think that we have a system worked out for that. All-weather reliability, we have been working on a location in Manitoba to do cold weather testing. Most of the airships of the past only flew in the summertime or nice weather. And even today, you never see a Goodyear blimp flying at in Minneapolis in late November, football game or whatever. And that's because those airships are not really designed to handle cold weather. The valves opening and closing and air moving in. In fact, a non-rigid airship is not really very suitable for cold weather operations, in my view. You can use them, and they did that in the U.S. Navy. Blimps, they operated in the wintertime and cold weather, but it's a much more difficult thing than, I think, a rigid airship, because you're depending on the pressure of the gas to keep the shape of the airship. We know, living in Canada, that you can go through 20 degrees centigrade in 12 hours. So going from a nice tight airship to one that's too lax to fly, or if you put more gas in and it warms up, you have to let the gas go. The management of that would be difficult. In a rigid airship, where the gas cells can expand and contract inside the hull, would cause no difficulty. You wouldn't actually lose any lift because the thicker, colder air would compensate for the smaller size.
And the rigid could have some heaters, because the freezing rain is hard for a heavier than aircraft, but for a dirigible, it's not the Led Zeppelin, but it's getting close.
Well, and part of the reason you see a solar panel in the one in the middle, the reason for that is partly some emergency energy, maybe relatively free energy, but it's also to remove ice and snow. Now, these are very big vehicles, 80 or 100 feet up in the air. You aren't going to get a broom to try and sweep that off. But the solar panels get quite warm as soon as the sun comes out. So being able to melt away ice or snow would be a great advantage with a solar panel. Maybe not covering that much of the airship, but there are people who are looking at solar-powered airships. And these solar thin films, which are relatively thin, because again, the trade-off there is, yes, your energy is free, but you're adding weight. So is it worth it? And this is one of those questions that you always have to ask about an airship. It's weight is the primary thing to think about. Obviously, you need high utilization rates and backhaul loads to make this all work. So the issues, where do you find the competitive service rates and times? Would you carry dangerous goods? Perishability, vehicle size. These are all issues that you could think about, but I have no doubt whatsoever that this will be a successful transport vehicle for general freight. And I think the biggest market is likely going to be replacing cargo airplanes, because the cost of this, even an airship of the old Zeppelin size, would be able to compete with a jet airplane. But if you get one that carries, say, twice as much, 200 tons, they'll put all the jet airplanes out of business, because very little freight needs to move that fast. If you think about the average speed of a truck or a train, that's all you need for cargo. You don't have to go 500 miles an hour. So, and of course, you get across the Pacific in 12 hours, and somebody sits in a warehouse 2 days. What's your average speed? So again, the speed is not everything in terms of cargo. Next, please. The craning one. Most of these airships, certainly the Atlanta, the Israeli airship, and the Flying Whales, they're looking at operating as cranes, as well as the ones that are the lenticular size. Obviously, you need vertical takeoff and landing, long endurance, flexible configurations. The issues are more difficult. Safety is one, ballasting is another. When you take off a load from an airship, it has a constant lift. you have to put some weight back on. So how do you do that when you're trying to deposit something, especially if it's in an area that doesn't have a lot of infrastructure to get that? You know, a lot of people, you know, the flying whales have talked about loading water. Well, loading water on its ballast is great if you have a water supply, but also dropping something off from the air and loading on water, as soon as your weight changes, your airship's going to be moving up and down. The other thing that we see about this is that none of these, they've done a lot of CGI with flying whales, but they always show them operating with no wind. You know, as soon as you have wind and this that cargo down below starts to move like a pendulum, you know, controlling the airship on the top end landing safely, again, I just think it's, you know, way too dangerous. So I don't actually have that much hope in many ways for these sort of craning devices. I think they look good on paper, but again, you get out into the actual operations, I think they'd be much more difficult to do.
With regards to stabilizing the load, couldn't they do like a 3-point harness, just kind of instead of having a single pendulum like load carrier, you could have multiple lines going down?
In fact, that was the design of the cargo lifter, the German airship that was came around the year 2000, and they had an idea like that. They'd have 3 points on the ground, and then going up to a center point, and the airship would be pulling up from the center point and holding that tight, and it would hold the cargo loading down from that and up. The difficulty with that, well, first, was never really proven, although they did have some experiments with it. The difficulty is you have to have a fixed facility. You have to get these things in place before you get there. So, you know, you have to have a pretty well designed out system to make it work. It could be done for wind turbine blades, I'm sure. Again, many of these ideas have never been tried because we haven't had modern airships, you know, and so we don't really know what would work and wouldn't work. But I think this is certainly a more difficult area, in my opinion, to make work as a market. Next one.
Okay. Oops. Where'd it go? Got
Number 20.
watching the things there. Got
So
too interested.
Resource extraction. You can see the flying whales are lifting the logs out of the mountains, and you can see all the propellers they have on the sides to hold it steady to do that. Something like a much simpler spherical airship. This is one that was built in Canada. You mentioned the one that was a Magnus effect. This is one by 21st Century Airships that was also developed. Well, they were using it mainly. It was for it never became really commercial, but they were looking at advertising and different things. But a vehicle like this, I believe, a drone vehicle that could lift logs out of the forest and take it to a transfer site, maybe only a few 10 kilometers away. Again, this is not very aerodynamic. That's the trouble. That was why they wanted the Magnus effect. But, you know, for 10 kilometers, it doesn't really matter. You're going slow anyway. But this would avoid building logging roads and a lot of the issues that go with that in terms of forestry. So it's something that may work. Similarly, for mining, when I first heard about using airships for mining, I thought, well, how is that going to work? You know, moving stone. But of course, you aren't moving stone. You're moving a concentrate. But it comes back to a question of, well, what's the cost of the next alternative? You know, building roads in northern Canada is exceptionally expensive because of the difficult terrain, as well as getting the permission to do it, which the government is struggling with right now. That's what this new bill is all about. But, you know, if it takes 4 or 5 years just to get approval to start, and then you have to build the road, and the road itself, for a gravel road in the north, the average cost here is between $3 and $5 million per kilometer. Now, that's not, you know, any given kilometer might be less, but you got to cross water and muskeg and swamp and rock outcrops, and we have difficult terrain in Canada. So building roads is expensive. An airship, more expensive than trucks. But again, if you have to build the cost of a road in, the airships look very good for moving concentrates from, especially rare earths. You're not going to move iron ore, but rare earths and base metals, yeah. And again, the needs, well, loading and offloading, low cost, ballasting and transloading. How do you do that? Next, please. This is the military. All these airships you see were designed for military purpose. The airship companies tried to find military buyers, and the U.S. at the top and the Russians at the bottom, and this other one is from Argentina. Obviously, they want to have some way of getting the load on and off. They confronted with that. So what you can see in the bottom of the one at the top is what looks like big suction cups, and they're modified hovercraft pads. So the idea is that the air blows down while you're moving around on the ground if you want to taxi or whatever. And if you need to stop to unload something, then you reverse the fans and it sucks the airship down. Sounds really good on paper, but it's one thing blowing air through fans down and sucking air up with sand and stones and everything else might come with it. So maintenance could be an issue. And of course, there's also the cost and weight for just landing and taking off. But if it's emergency or military, those costs seem to matter much less. It's will it do the job? So they have set these up as being heavier than air, about maybe 80 to 70% heavier than air, and using the, no, sorry, maybe the other way around, 20 to 30% heavier than air, so that they can drop off a load and then they can return unloaded. Again, in theory, still to be proven, and see where that goes. But ability to land on water or ice, move around independently, certainly certain appeal to this design.
Yeah, or maybe the flying whale with the propellers at the top. That's a way higher up above the pieces of dirt, sand, and
That's
ice.
right.
So
Yeah.
that kind of would eliminate or lessen the need for a big ground crew who can occasionally get picked up, which was one of the reasons that the dirigible program died in the United States.
Well, yeah, I mean, today, none of the airships are looking at big ground crews, and they don't need them. I mean, the reason for the big ground crew is really because you have no control at slow speeds. One of my friends used to describe it. He said, imagine you're in a power boat in a calm day with the engine turned off. You can turn the wheel any way you want, but it doesn't affect the motorboat because there's nothing moving past the fins. So, the people holding the ropes was duty just to control them, to get them to the mast. Today, with vectoring engines that have pushed the air this way or that, none of the airships are looking at ground crews of more than a person on the ground, maybe to help connect something. They will land autonomously, and I think they'll be able to do that. Certainly, the Zeppelin NT, which is now about 25 years old, have been flying this for 25 years, and those are the three airships that are now flown by Goodyear. They don't have any ground crew like that, so it's been proven to be done.
Okay. Want to go to the one?
Unless there's other questions about this, yeah.
Nope.
Number 22. Well, this just really talks about, like the massive potential. Why Canada, for one, we have so much land that's inaccessible. 70% of the country has no roads. The airships would work beautifully and serve that. But there's also a huge industry here. If you look at all the possible inputs into an airship. Now, a lot of these inputs already exist. Engines, propellers, fabrics, lifting gas. Nothing really has to be invented that's new. Things have to be modified. But the aviation supply chain already has all these things developed. It's just a matter of design them or refine them for an airship. So on the operations side, there's lots of things that would go into building airships. And then, of course, for passenger and cargo, you have different markets that would develop from that. Transport's interesting in that developers of transport never really see the full benefits of their development. Most of the benefits are for the users of the transport vehicles, and of course the countries that with them. So there's a huge number of forward and backward linkages that would be associated with this brand new economy that doesn't even exist today. If the airships, they are sort of the key part. I always like to tell people about Western Canada. Before the railways got to Winnipeg, where I live now, there was nothing here but a stone fort and a few fur traders. And the railway came, and within 30 years, the whole of Western Canada had blossomed with farms and activity, and Winnipeg was the third largest city in Canada. And it didn't stay there in terms of its size, but still a big city and a big operation. Well, none of it would have happened without the railway. And it was the transportation that altered the opportunity. And the same thing for the North and many remote parts of the world. And it's not just Canada. The Amazon, the Congo, the Outback, Siberia. There's many places in the world that are very difficult to get to that would develop better if they actually had transportation. So this just illustrates a few of those ideas. Next, please.
You mentioned lifting gas in that last thing. Are you going to talk a little bit
happy
about
to.
hydrogen and helium? Yeah.
Yeah, I think a lot of people have this vision that hydrogen is so dangerous that we can't use. It's not true. In the first place, the physics of hydrogen, you need to have a 4% concentration in the air for it to ignite. By comparison, gasoline will ignite at 1% concentration of fumes. So gasoline is much more dangerous than hydrogen. Plus, gasoline is heavier than air. So when you have a gasoline leak, it hangs around at your feet. And of course, it can easily ignite in the concentration you can reach. Whereas hydrogen, as soon as it's released, goes straight up. So unless it's captured in some crevice or whatever, you're not going to have the concentration to ignite. It's actually quite hard to ignite. People have tried in different experiments. The other thing is, if you go back to the 1930s, I mean, 87 or 80, 90 years ago, people didn't have the technology we have today to be able to detect hydrogen. They knew it was dangerous because they'd seen it. You could have, it burns very rapidly, is why you get an explosion. It's like a dust explosion, same principle. It's the combustion so rapid that you get an explosion. But of course, how do you detect it? You can't see it, you can't smell it, you can't taste it. But today, you can buy a handheld sniffer for $150 on the internet that'll pick out parts per million. And in the case of hydrogen, it will not ignite at less than 4 parts per 100. So as soon as you start detecting hydrogen, as long as you ventilate an area, you can't have an explosion. Now, where you see this today is in warehouses. Any warehouse that has electric forklifts, you're going to find a room in that building that's going to have great racks full of these big batteries that are being charged. And when you charge 12-volt batteries or lead acid batteries, you get hydrogen coming off. This is why you get the instructions for your car. Don't do this in a non-ventilated place. Well, there's a lot of hydrogen coming off these big batteries, and you never hear about an explosion in a warehouse. The reason is they've got the sniffers and detectors, and as soon as the hydrogen reaches whatever level they determine to be safe, fans come on and they ventilate the area, and you don't get an explosion. So the ability to use hydrogen today with an airship is much, much safer, and we know a lot more about it. And we also have better materials. All the old airships that were out there, they were leaky unbelievably leaky. But the only one that had a really serious accident on a fireball on at a mast was the Hindenburg. Well, it was number 129. The other 128 Zeppelins did not have that accident or an accident like that. So again, in our minds, we get this, preponderance of belief that the Hindenburg is, killed the airship industry. It's not true. Yes, people were worried about the gasket didn't have the detectors, but it was the jet engine that killed the Hindenburg or the airships after the Second World War. By 1949, the first jetliner came into production, which was the Comet out of Britain. Well, it was so much faster than even the propeller. It killed all the propeller airplanes. It killed the transcontinental railways. It killed the ocean liners. The airships never had a chance in that. And it was only a passenger market that we used. There was no freight market to speak of. So there was no need for airships and no investment went into them. Whereas airplanes received huge public investments in the Second World War. And then after that, the Cold War. So we got the supersonic, the Concorde, we got amazing investments into airplanes. And
the jumbo jets, 747 and its competitors.
Yeah, again, they basically, as I understand it, the Boeing company lost the contract for the big military cargo jet. And they came up with the civilian 747 and, of course, made a huge amount of money from that. It was the best race ever to lose in the world. But in any case, the use of hydrogen, the advantage of hydrogen also, you can use it for fuel as well as lift. So imagine you're up north somewhere and you have an accident where a gas cell rips and you have to get gas. But if you're using helium, how would you get it? You can't carry compressed gas on an airplane, and if you wait for a sea lift, you'll be waiting a long time. With hydrogen, you can duct tape up the hole and puff it up with some hydrogen from your fuel tanks and limp home at least and get home. Back to those materials. People maybe know, maybe they don't. The gas cells in the Zeppelins, they used the sort of a big square of cow intestine that had been dried, and they pasted these onto linen sheets, and where they overlap, they wet them. They seal perfectly, but those intestines, those gas cells only lasted about 4 years, and they were leaky even at the best of times. So the materials they had to work with. Whereas today, think about a tinfoil party balloon. You get one of those, you get tired of it. Like, will that thing soon please go away? Because you had it for a month after your birthday. It's still sitting there full of the gas. Metal holds gas very well. So metallized fabrics for holding gas is, of course, much, much better. But in any case, there's materials, there's safety procedures. And if I go one step further, in my own opinion, we're going to use drone airships, not maybe for the passenger tourist things. I think the regulators will always be nervous, and maybe helium will be used for that purpose, and that's fine. There's plenty for that. But if you're looking at cargo, I think the future will be drone operations. And if you've got nobody on board, then why would you even care about what the gas is? So, especially going up north. So in our view, hydrogen is going to be the way of the future.
Yeah, although your insurance rates would go up if you lost too many drone freighters.
Insurance always.
Mention the cost of the.
In fact, insurance will be very expensive initially because they've got no record. But once you get established, what is the safety record? It just goes back to risk then. It's not uncertainty. Right now, it's uncertainty. So they would charge a lot for insurance, no question. But sort of my conclusions of my presentation are that, first of all, you have to have high utilization rates. Whatever you're going to do, you have to have enough markets. So, and of course, it has to be decent paying freight. What we observe is that the more valuable the commodity, the more it can pay for freight. So you're not going to move raw materials very much. You're going to move more manufactured goods and higher value materials. Fruits and vegetables may be the exception in that regard. The greatest advantage of the airship is size. There's no such thing as a small airship. It's also the greatest disadvantage of an airship because you have to have a very large building to build them in, and it takes time to build them. Perhaps one of the greatest impediments to be worked out is how do you produce them fast? Again, all the parts are going to come together in an assembly facility, just like we do anything else with aviation today. Nobody builds anything from the ground up in one spot. But orchestrating that material to come in and build something that's as big as an ocean liner, and doing it fast, again, that's a challenge, I think, for the industry. Environmental strength, ease of electric propulsion, that's a tremendous benefit. If we start to, become more serious about climate change, and even as I sit here today, I can kind of smell a bit of smoke in the air. The forest fires here in Canada are unbelievable this year, and as they were in California and other places around the world, simply because the climate is changing, and this is just the first warning shot, I think, about climate change. There's a lot worse to come. We're going to have to get serious with carbon emissions, and the airship will certainly, even if it just replaced the cargo jets, would be a great advantage, because jet airplanes account for about 2% of the world's carbon emissions alone, just that one technology.
Yeah.
And then finally,
worse, there's soot from jets. Think of flying buses, giant flying buses, putting their soot in the stratosphere. That's worse than any carbon dioxide.
Yeah, what I've read is that their emissions are about 2 or 3 times more damaging than emissions at ground level, just because they're up very high. And so I agree with you. It is a problem. Finally, horses for courses. The airship design depends on the cargo. What do you want to do? Is it fast and long haul? Is it short? And is it specialized equipment? I believe that when the dust settles, there will be half a dozen different airship designs for different purposes. There's not just going to be this airship design. If I could move down, I've got a couple of slides at the end I want just to show you. The next one, that one, yeah. I like to point out to people that, in the 1920s, electric cars were available commercially, and they were beaten out by the gasoline cars. Better range, better performance. The fossil fuels were cheap. There were lots of reasons for that. But today, you can see this is probably that little girl's great-granddaughter charging up an electric car in her garage, and electric cars, notwithstanding some setbacks that we're seeing, they're still coming forward, and that's likely the way we're going to move into the future. So electric cars are back. Next slide.
Yeah.
Wind turbines. They were all over the prairies and the Great Plains of the US. They were used very widely. They disappeared in the late 40s, in that period when the coal-fired power plants came along and the fossil fuels beat them out. And today, wind turbines, one of the fastest areas of energy production and profitability. So they're back. And then the next slide, you see the Los Angeles on the left. That airship was built for the US Army by the Zeppelin company after the war.
Yeah, part of their reparations.
It was reparations. Flew huge distances. I don't know how many years it flew, but it was finally disassembled. It had lived this time. Never had an accident or any incident. Flew beautifully. The one beside it.
Two American Zeppelins did crash with loss of life.
Yes, the Akron and the Mako. Actually, 3. The other one was the Shenandoah.
Yeah.
Which was a big Zeppelin. But again, a lot of this had to do with storms. Every one of those were in a storm. The thunderstorm for the Shenandoah, and a very bad storm off the Atlantic for, I think it was the Macon, and the Akron off of the Pacific. One of the things that people don't realize is in those days in the 30s, 15 minutes after they left the port, the pilots had no idea what weather they were running into.
Mm-hmm.
And if you run into a thunderstorm with an airplane today, you're going to be coming down too. You don't go into thunderstorms. And so the airships today, their safety record would certainly be a lot better. In all the cases that we mentioned, it wasn't their maiden flights. They'd flown quite a number of flights, but
Mm-hmm.
after a while you hit that storm that's out there that
Mm-hmm.
you should not have been into. And of course, the airships just were not capable of dealing with those stresses, which brings another point. You have to remember that that airship on the left, the only thing they had to design and calculate the stresses was a slide rule. There were no strain gauges when all these airships were built. The strain gauge was invented in 1938 after the Hindenburg was done. And today, you'd never build something like that without a strain gauge. In fact, that I'm told that LTA research is just covered with strain gauges, testing to see what's happening with all those tubes it has. So again, the structure's stronger, the weather forecasting, better materials. In fact, what you see is the one on the right, the Zeppelin NT. Perfect safety record. Been flying continuously for 25 years and never had a problem. And it's, again, a semi-rigid airship design. There's a frame inside, as well as gas under pressure to hold the envelope, takes about half the stresses.
Is that the little sightseeing dirigible?
It's the ones Goodyear's using. They have 3 of them. So it's the very same as this. It's what Goodyear now uses as the Goodyear blimp. It's not really a blimp. It's a semi-rigid airship. So again, everything that's old is new again. And those other 2 markets are there. The big difference is the barrier to entry. To build a electric car, you can do that in a small garage. A wind turbine, you can build one that's 20 feet high and then 30, 50, keep on going. You can scale up. An airship is useless at, 50 feet. You can't do anything, hard to lift itself. You have to be big enough to be able to displace enough air before it is of any value. So that means you have to have a big building to build it in and, a big machine to build and test it. So it's very hard to get started in this industry, which is why you need a guy like Sergey Brin, the co-founder of Google, to financing LTA research, or the French government building flying whales. So the next one down, please. This is my last slide of my presentation. So the best option for the North, we think, is the airship. And the second best option anybody can come up with so far is a catapult to just fling things into the North, because we really don't have another alternative. This is why, we've been following this and working with this so long, is that, nobody has come up with an alternative. And so until this is really tried, we can't dismiss it. And over time, the idea has certainly gained more currency all the time. We're now at the stage where I think it's going to be the money is going to be put forward to find out, will this work or not? And I'm sure it will. I mean, they've been working for 100 years. It's not an anti-gravity device that you have to wonder, will it work? I mean, we know it'll work. It's just a question of whether it's economic.
See, and now it's actually more than 100 years. There were dirigibles dropping bombs on London in the World War I.
Yeah, I think it's actually around the year turn of the previous century was the first Zeppelin. So yeah, it's 125 years. I mean, it's overdue. I think we would have done this. We would have done this 50, 60 years ago. In fact, if it hadn't been for the jet engine, I think people would have revived the airship. But the jet age is just what it was. It was the jet age. And, people were interested in speed. They didn't care about emissions. And, and a whole tourist industry around the world was building. I love passenger jet airplanes too. Don't get me wrong. I love all kinds of transport. I'm not out airplanes. They have their role and their place. But if you're moving cargo, um, the airship actually has a lot of advantages. Maybe we could stop this and let me talk a little bit about, actually maybe instead go
Mhm.
up to about the fifth or sixth slide, maybe a little further. Let's see.
Let's see, here's 5.
Oh, okay, sorry. Come down past 10. Keep coming down.
Here's 10, 11.
Next one down, maybe a 2 or 3. I'm looking for the airships, the one that has a pic there. That's the one, the first one with the airships. Okay,
Mhm.
if you see the one in the upper right, what that airship is sitting on is a rotating base, essentially a very large turntable.
Mhm.
And the reason for that is that if you have an airship that's on the ground, you have to be able to control it to get the cargo on and off. Now, it's one thing for, having a few passengers jumping on and off, which they do with the Zeppelin NT. But if you're moving not hundreds, tens of tons of cargo, you have to have some equipment to do this. And you have to be able to do it safely, and you have to be able to do it fast.
Mhm.
So in the case of that turntable, it's designed to have wind sensors. So if the wind starts to change, the turntable automatically moves the nose into the wind. And, the idea is that, an airship at a mast, the reason it's at a mast is if the wind changes, it's going to swing around. What people don't realize is that airships are also very unstable in pitch. So when it's at the mast, it's also the tail is moving up and down at the end. So you have to be able to control that to get the cargo on and off. So if you can land on a turntable and latch it down on the turntable and turn it so that when the wind changes, it's going to hold its position, you can then back trucks up to the turntable and you can transfer with a forklift from the truck onto the turntable to the airship.
Mhm.
So this is the logistical system we envision for being able to load and unload. And again, I think the industry has done itself a disservice. And then you hear people saying, oh, we'll just land anywhere. Well, it's true that an airship can just land anywhere. And that's one of its safety benefits. If you have trouble, you can just land anywhere, preferably on a lake or water. But in any case, if you're going to just land anywhere, how do you get the cargo on and off? How do you move it on the ground? How do you do it quickly and safely? I always tell these guys, look, your third day in a muddy field will be your last day. You're not going to be moving cargo that way. So you have to have some infrastructure. And if you think about transportation systems, which is, that's my area, there's no transportation system for cargo that doesn't operate from a prepared base to a prepared base. Ships come into ports and have docks. Airplanes land at airports. Railways have sidings. Even trucks have loading docks. And if you don't have those things, it's very hard to actually load and unload the equipment. So the airships similarly have to have a proper infrastructure. Now, there is a cost to that, of course, but again, if you use multiple airships and you're using it a lot, if you're coming to the same place every day, it's back to utilization. You can make it work. So this is something that people don't talk about very much, but we think is extremely important
Mhm.
is infrastructure on the ground and how you handle the airships. Because again, I always tell people, if you have any accident, your operation is going to be suspended. You end up killing somebody and you're going to be out of business because there's no tolerance any longer for any kind of accidents to occur. And so you have to be able to design your system to be absolutely safe. And so anyway, that's the
Yeah,
last point I wanted to make.
right. In passing, turntables been around for railroads, not a century, but a century and a half. So yeah,
Easily.
turntables. It's
Good.
technology that's available.
Yeah, I mean, there's nothing new there. I mean, there is a few things about it that, we've been working on. It's not quite as simple as you might think because, again, that turntable you see in the picture, it could easily be something like 300 feet in diameter. So it's going to be a big turntable. But again, we don't think that's really a game stopper. It's just a matter of you have to design it to do the job.
Mhm.
I really appreciate your time today. I see we're about an hour and 40 minutes into this.
Well,
Yeah.
I guess we
I
should
feel
have
a little
talked
guilty, but
faster.
I'd keep you longer.
That's not a problem for me, as long as it's not a problem for you. I did have one last question that I'd love to get answered. In the research that I've done about airships, there's legislation that basically says you can use hydrogen as a fuel, you can transport hydrogen, but you are not allowed to use it as a lifting gas. And that was brought in from the helium lobby many years ago. But I see that your design is for hydrogen, and it looks like many of the other ones as well. So is that still an issue?
Oh yeah, I mean it's still an issue with the regulators because the regulators haven't really been forced to deal with it and aren't really confronted with it. Uh, in Europe, they already have new regulations on the books. EASA, the European Air Safety Agency, I think it's called. They have new regulations that state that an airship can use any gas that you want. You just have to prove you can do it safely. So safety is the issue, and that's what regulators should be involved in, is safety. I mean, it's rather ridiculous to think about, you can use fuel in a compressed container on an airship, that's okay. But if it's ambient hydrogen, sorry, did I say helium? Ambient hydrogen and compressed hydrogen, well, which would be safer? I think that, anytime you pressurize something, you got more risk than if it's just at atmospheric pressure. So it doesn't make any sense really, and it's just a matter of time. But I think in the case of operating as a drone, what's the safety issue that people are going to be, especially if we're talking about our north. So, the regulators are very conservative, and we're not unhappy with them being conservative. Safety is important. We don't want to fly in unsafe airplanes or unsafe airships. And it's a matter of designing them and building them so they are safe. But I think it can be done easily.
Yeah, thank you very much. Did you have any final questions, Roger?
Nope. I have a bunch, but I'll be good. Maybe we do this another time and have what's happened some more. Uh, I'm sure there'll be more things happening. So yeah, all I have to say is thanks again. This is wonderful stuff. I knew about better coatings on the dirigibles, but the thing about the gas bags I had not heard. So that is an important thing because, like you say, there would be minor leaks going on all the time. So that was another thing that made the Hindenburg a doomed ship when they went into the thunderstorm.
Well, you have to remember that all the Zeppelins actually vented hydrogen. That's how they controlled their buoyancy up and down. And they did it safely, and there were no accidents. Again, people's conception of the safety of hydrogen is just skewed by the misinformation. And in fact, the poor folks in the hydrogen industry, they suffer the same thing. You're trying to deal with hydrogen-powered vehicles, cars, or school buses, or whatever. Everybody wants to. The Hindenburg. People dredge this up because they think that somehow it's inherently unsafe. Every gas is unsafe if you mismanage it. But if you manage it properly, of course, then it isn't. It's just a matter of protocols and technology. And I think, we know a lot more about hydrogen now. It's being used all over the place. So I think it's just a matter of, time. But it has been something that's held the industry back. There's no question.
Yeah, because there was the Hindenburg, the R101. I forget the name of the French had a big dirigible that disappeared in a flash, literally.
They did.
So,
no, again, but, one thing I'd point out to you, Roger, is there was a lot of fixed-wing airplanes crashed too.
Yeah.
Huge.
My brother-in-law actually
really dangerous, and in fact,
my brother-in-law was in a crash. Their engine went out, and they found they said, let's see, where are we going to crash? Okay, not in the stumps where they'd just been logged, because that was the end again, friend. We'll go into the trees. They bounced into the trees. Plane was hanging upside down. They were about 10 feet from the ground. They cut their seat belts, dropped to the ground, and called for help. And the rescue crew came out. They, oh my God, we're going to be picking up bodies and such. And I said, hey, you guys are fine. Guy had the other guy had a black eye, and I think had some little bruises, but nothing serious. Plane was total.
Well, they were very lucky. They were very lucky.
Mhm.
There's an interesting statement. Someone believed that there's a heck of a lot more submarines at the bottom of the ocean than there were ever airship accidents. But again, we don't know about them because we don't see them. The great problem for the airship industry was that they were caught on film and they were very dramatic. And as a result, people were afraid. But I've seen lots of jet airplane crashes on film too. We had one in Toronto that flipped over on its backside on an icy runway. Fortunately, miraculously, nobody was killed in that. But the airplanes are certainly actually less safe than airships. I don't want to say that too loudly because I don't want to make nervous travelers, but
Yeah.
airships are actually very, very safe. But you combine what would be limited engineering ability and understanding of stresses and tolerances on and they were all experimental aircraft. None of them were manufactured in a series. The Zeppelins were the closest to that ever happened. And of course, no weather forecasting. So there were lots of reasons for these accidents that we can look back on now and understand. But the general public still has a misinterpretation, which I'm hopeful that once the airships start to fly, that'll all evaporate very quickly.
We'll be back into similar thing, public relations with fission reactors. They built a lot of giant one-off reactors, and when they were at 3 Mile Island, they said, 3 Mile Island.
Yeah.
Said, wow, if this overheats, it'll mess up a whole state like Pennsylvania. Whereas small modular reactors, if you have an accident, you hit it with shotcrete, the crane comes, puts it on a truck, and it goes back to the factory that disassembles. So hopefully the same thing. You'll see a lot more SMRs.
I'm very much in favor of the small nuclear reactor. I think that's actually a really interesting technology, especially for the north, where you have mining operations or remote communities and so on. I think, in some ways, we live in a really interesting age. We're in a transition in some ways that's forcing us, climate change and all the effort, the technology is forcing us to change. And there are some really interesting and exciting things that are coming down the pike. We could spend a whole program just talking about solar panels, I'm sure, because that's maybe the one that has the most interesting potential impact on our economy. And it's coming along fast.
Yeah, and it's the photovoltaics have beaten out the thermal to a large degree, and it's kind of sad. There's 3 big central towers gone the way to Las Vegas from LA, Ivanpah, and they're not making a profit. They're thinking of shutting them down. They are so impressive. You can see them from distance, like they're 3 little suns up in the air there.
Yeah. Yeah, it's pretty very easy to spot when you're flying. Well, we flew from Edmonton to San Diego a few years ago, and you can see they have large, PV arrays, but then you see these 3 really bright reflectors, and it kind of interests me. Like they were using a different technology because they were trying to make it like they were using salt technology, which the intention was to increase the length of time that it could generate power. But as far as I know, the solar towers that are operating in Spain are super simple and they're still profitable. So maybe they made it too complex in California.
Yeah, well, they're purists. You could just use gas when the sun goes down. And so it's a hybrid tower. It uses a lot less methane because in the sun it's pulling its heat all from there. No, just like magneto thermodynamics. No,
Hydrodynamics for submarines.
they have magnetohydrodynamics. They wanted to run a hot gas, and you have your electrodes were sacrificed. It's feeding off a roll because the electrodes are going to be melting. So you'd be at 1,000 degrees C hotter. However, the senator from West Virginia said we got to make it a coal-fired magnetohydrodynamics plant, and that made it so expensive. And they had so much trouble with sludge from the coal and carbon deposits here and there. And then the development stopped. They gave up on it because it didn't work. Well, maybe if you just started with burning methane, or eventually that would be a stepping stone to a fusion, possibly. But they couldn't do that. Had to have coal.
Anyway, thank you very much, Dr. Prentice, for this very insightful presentation. I feel like I've had a crash course in transportation and economics as well.
Well, it's a pleasure to have an opportunity to talk with you, and also I think to just get the word out to the general public. This technology that's coming, and we need it. It isn't just a novelty. There's a real use for it. We have some significant opportunities to better our world because of this. And so that's one of the reasons I've sort of stuck with it. So thank you also for the opportunity to talk, and I wish you well in your future broadcasts.
Okay. And we'll send you the URL so you can look at our comments for history. And hopefully getting to other people, as you say, getting the word out.
Sounds great. All right.
Okay.
Well, thank you so much.
Good night, and thank you again.
Thank you again.
Yeah. Bye. Yeah. And see, almost 2 hours. That was great. Oops. Oh, I guess I'll
stop the recording.
Yeah. Stop sharing. We're just chewing the fat now. Whoop. Stop share, and then actually, yeah. So that'll be good. All right. I think I might have some people talking about fire safety for houses and things. So I can get an architect together. There's a company that has hey, we make little fixes. And I'm sure.
Roger, you're still recording as far as I know.
Oh, whoops. Oh gosh, I'll have to cut this off. Why is it? I thought I said.
You stopped the screen share, but it still says recording on the top.
Let's see. Yeah, it does. Oh, why don't I end the whole thing? Pause, stop recording. There we go.